Good day to you, students. How are you doing? Today, we'll be dealing with a subtopic in chapter 8.2. The subtopic is titled Power. Power is the rate at which energy is transferred or the rate at which work is done. Power is also the rate at which a force does work. There are two ways to increase power. A. Lift an heavier object in the same time. B. Lift the object more quickly. Machines and people do work and their power can be talked about in the same way. For the first activity of the day, we are to fill in the missing words. A crane does work when it lifts a, what do you think will be there? Alright, so you fill it in, you have load. The bigger the load and the faster it lifts the load, the greater is the power, okay, of the crane. A locomotive pulling a train of couches or wagons does work. The greater the force with which it pulls and the greater the speed at which it pulls, the greater is the power of the locomotive. So let's check. That is correct. So we move on. How to calculate power. Power can be written as power is equal to work done per unit time or work done divided by time taken. It is also equal to energy transferred per unit time or energy transfer divided by time taken. Power is represented with P, work with W, T with time, and delta E with energy transferred. Power is measured in watts. 1 watt is equal to 1 joule per second. 1000 watts is equal to 1 kilowatt. Or 1 million watts is equal to 1 megawatt. There exists the idea of power to any transfer of energy. The efficiency of an energy changing device to the power it supplies can be written as efficiency is equivalent to useful power output divided by power input multiplied by 100%. This is compared with the equation for energy efficiency in terms of what? Energy. As efficiency is equal to useful energy output divided by energy input multiplied by 100%. So we have to deal with this activity. Alright? So let's start now. A car of mass 800 kg accelerates from rest to a speed of 25 meters per second in 10 seconds. What is its power? You already know that what? Power is equal to what? Energy dissipated per unit time. And energy also is related to what? Work divided by time. That is equivalent to power. So let's take the known and then know where our unknown lies. That is, we are going to calculate power. M is 800 kilogram. The velocity now, or speed rather, is 25 meters per second. Then time is what? 10 seconds. Since the object is moving, that is the car, that means energy in this case will be related to what? The kinetic energy. So power now is what? Kinetic energy divided by what? Time. What's the definition for kinetic energy? Half mv squared over what? Time. So we have power to be what? Half times 800 times, now we have 25 all squared divided by, we have 10 seconds. So power now is equal to half times 800 times 25 squared will give us 625 divided by what? 10. So we now have 400 times 625 divided by 10. This will cancel what? This. So we now have 625 multiplied by 4. So this is 20. This is 10. Remember one. This is 25. Multiplied by 10. We have 25,000 watts. Now, if we should have 25,000 watts, don't forget that what? 1,000 watts is equivalent to what? 1 kilowatt. So for me to be able to express 25,000 watts in kilowatts, that will give me what? 25 kilowatts. So let's check if 25 kilowatts is available. Yeah, that's true. So let's click it and see whether that's our answer. That's correct. So we also have another question here. Let's solve it. A light bulb transfers 1,000 joules of energy in 10 seconds. What is its power? So power now is equal to what? Energy transferred divided by what? Time. And energy transferred in this case is what? 1,000 joules divided by what? 10 seconds. So this will cancel this. Power now is what? 100 joules per what seconds. 1 joules per second is what? 1 watt. So we have 100 watts. Let's pick 100 watts and see. That's correct. So another question, it is estimated that the human brain has a power requirement of 40 watts. How many joules is that per second? Don't forget that what? 1 watt is equal to what? 1 joule per second. If you should now have 40 watts, that will be 1 over 1 joule per second over 1 watt times what? 40 watts. So watts and watts will what? Go. So we are left with 1 times 40, that's 40 joules per second. So let's pick 40 joules per second and see. That's correct. So looking at this particular question, it seems tricky, but let's try and solve it before we pick our answer. Now, a boy and a girl run up a hill in the same time. Don't forget that time for boy is equal to time for what? Girl. The boy weighs more than the girl. That means weight of boy is greater than weight of what? Girl. Which statement is true about their what? Power. So if our power now is equal to that's weight Okay, we are dealing with what? The weight rather. Okay, now weight, all right. So power is what? Energy divided by what? Time. So if they are to run up a hill, that means they are what? Their height will be what? And present. So we now have, in this case, gravitational potential energy. So we have mass times what? Gravity. That defines what? The weight times the height divided by what? Time. They are using the same time. That means TB, in this case, is equal to what? TG. But the weight of the boy is greater than the what? The weight of the girl. Now, what is not specified here right now is the height. We don't know the height of the boy, neither do we know the height of the girl. I mean the distance covered in moving up for the boy and the distance covered in moving up for the girl. Probably that the distance covered by the girl in terms of the height is what? Greater than that of the boy, or that of the boy is greater than that of the what? Girl. That is not what? Specified. So with that, we only know that the weight of the boy is greater than the weight of the girl, but they have the same time. So they now ask which statement is true about the power produced. They produce the same power. That statement is what? Is false, because we don't know the height that is involved. The boy produces more power. This is not certain due to the height also. The girl produces more power due to the height is not certain. It is impossible to tell who produces more power. Yes, because the height at which they climb is not what? Specified. At least they run up the hill is not specified. So let's pick that and check. That's correct. Now, let's choose the correct statement before we wrap up the class for today. Power is the rate at which a work does force. That statement is what? Is wrong. Because force needs to come before what? Work. It is force that is applied that will produce what? Work. Power is the rate at which energy is consumed or used up. The energy can either be created or destroyed, but can be converted from one form to what? Another. So energy cannot be consumed or what? Used up. It can only be converted. Power is the rate at which a force does work. This statement is what? Correct. So we pick it and see. Now we've come to the end of today's class. Do want to visit our website www.edubbey.com for more of our interactive notes and what? And videos. Subscribe, and subscribe. Bye for now.